Hi, everybody. Welcome. We are super excited to have Esmaeel coming all the way from Penn University, and we are just really, really lucky to have him. He does advanced work for his PhD on remote sensing. He's an expert at Google Earth Edition, as you will find out soon. And yeah, we're just really happy you're all here, ready to get going.
Thank you everyone for being here today and for all the people for organizing this workshop. So let me immediately try to address, we have 2 days ahead. So let me immediately try to address like what we are doing here at Visit Worthwhile, going through today and what we will be looking at exactly. So we start with like why essential and what actually it is, then like how it is used in the research, how it's used to communicate the results and applications. And also look at how we will look at learning association and the geospatial landscape in 2026, what would be different. Then we will look at what we will look into exactly in this workshop. So why Google extension or what is it? We can start with like looking at the massive satellites and networks and sensing data that is available out there. We have like petabytes of remote sensing archives data that is available. And Google team started to think of ways to of rather than shift of the traditional way of analyzing remote sensing data, which is instead of bringing the data to your analysis, to your research questions, why don't you bring the research question to the data? When you have the data, that much massive data, it's not practical to always try to download the data and bring it to your research question. Probably put it when the data somewhere and bring your research question to the data. So that's when they started to build a petabyte of Earth observation at a time. And that includes the official Google Earth Solutions data catalog with many satellites data, including the entire archive of Landsat from the 1980s, the entire archive of Sentinel, actually not just 1 and 2, also the other Sentinel family, entire archive of MODIS, you have climate data, charts, Era 5 reanalysis, more than 50 years of reanalysis data, in addition to a lot of land use that cover data and many data from various agencies. We also have the massive archive of community data. That is data that were contributed by the community. And we will dive into both of these archives to know what is accessible there. But this is the data that is hosted there. So how is that different from traditional workflow? In traditional remote sensing and geospatial workflow, you download the data, you process it locally, and then you also need to find a way to communicate your analysis and results to others. Well, Google Essential workflow data lives on the Google server. What you do is you open your browser and you write a request of the analysis, what you want to do, and that will be sent to Google server and process it, and then you will get back the results. So how does that exactly look like? You will open the browser and you work on the browser when writing your request. This request is packaged as an Earth Engine object that is sent to the server, that will process it, and then you get the results back. And this is exactly what we will be focusing on with them. How to access now, there is the JavaScript API that we will use through your browser to write these queries. There is actually another API, Python API, that works both on product and local Python environment. Both are not that different, the same capabilities, but the native environment is the JavaScript one that is enable multiple user interference and advanced user interference. The other part that we need to highlight is both of these syntax, the JavaScript and Python, are the way to communicate with the Earth Engine library, which is the main syntax that we'll be focusing on, essentially. And this is the same whether you are using the JavaScript or the Python. The Earth Engine methods and library will still be the same. So what kind of analysis we are talking about with that when we are saying that liquid radar? It's literally almost one of the things that we can do with the report sensing, from the image analysis to the typical spectral indices, land-free composites, land cover classification, change detection. When it comes to time series, analyzing vegetation trends, aggregation, different type of aggregation, and anomaly analysis, and in addition to exploring the time series and exporting it. The same also for exporting this data and doing some zonal statistic on area and on sensitive images. So this is a few from the early examples that were enabled by this word and shared. So what you are looking at is an example of the count of pixels for the entire landscape archive. Now, maybe it's not so useful for entire analysis, but the thing it is an example of things that were enabled to see that we were unable to see it before about the availability of Essential. Another example is like you can look at the daily composite of models. You are looking at the enhanced vegetation index at the global scale. This is produced by fitting harmonious model of containers of modest enhanced vegetation index to look at the seasonality. Other examples is time lapse, where you start the satellite's image for many years, decades of data. To look at this example, we are looking at urban growth. The same for deforestation. This is one of my favorite animation, is the eating heart of vegetation. Just looking at all the NDVI time series animation. And this can be like done, most of these can be done in Essential in very short line of code to do. But this is cool stuff. Let's talk about like how it is used in research. So this is the paper that officially introduced the Google Essential, though it has been around for more than 7 years prior to this data. And there are many to this paper, and there were many key publications before that using it. And this figure is from a recent meta review paper that looked at the paper that used Essential. So you can see just the use of Essential in general. It has been mentioned more than 40,000 times now. It increased rapidly, and in the literature, especially for land use land cover, it's also now around more than 20,000 times. This is also another few examples from key studies that use Essential fairly on. So this study from 2013, published in Science from Barry Hansen. They looked at the high resolution forest cover changes. So they looked at the loss and change of forest at a global scale. They use the entire landscape archive, and that's a huge advantage to it. Another example is also looking at surface water, non-surface water. The same with this paper published in Nature 2016. They used Earth Engine at the global scale, entire landscape archive, to look at the changes in the global surface water, identify all the area shrinking and expanding and the changes. This data actually now available. Both of these data are available as data in Earth Engine, so you can also access that and explore it. Another example of from the early examples that we're utilizing Earth Engine is scaling the tropical mapping. So also they fit at a very high resolution. This was published in Remote Sensing of Environment 2015. So the domain and area that we're utilized in is really vertical. You can see like growth mapping, forest, water, wetland, climate change, public health. And when we try to cover like some of these few key topics, we try to pick up few examples that is covering these main applications that were covered in this workshop. There is also, after you done your analysis, then you want to communicate this analysis. So look at traditional way of communicating that, we would look at static maps. We used to look at static maps. Sometimes we also do web map using different tools, but it's always also required some level of expertise. Now with this engine, it is so easy to communicate your or share your scripts and analysis. Can always share only any of your script that some other people can run your entire analysis. You can publish your maps immediately as a web map for others to see, and you can also build an interactive apps to explore your data analysis in detail. So this is a quick example looking like you are publishing a paper and you can go with the static figure when you publish the paper, but you can also accompany it with a web-based small app interactive that can explore this for users to explore this data. It's become very handy when you are using like regional scale data, many years data. You cannot really go and get it effectively using all of the stuff involved. And Engine make it very easy to make these apps available. So this is other examples of the apps where built. It could be more elaborative. This is like looking at the surface water, exploring nightlife. Another example is this climate engine. And this is an example of using the app not just for communicating the results. This is climate engine is built on top of Earth engine as an interactive way for analyzing and downloading climate data without using script, without coding. So they this is made different way. Looking at all these things now, and we decided that okay, it's worth to look at visualization and there. But then when Jen and I talked about this workshop, the first thing that crossed my mind, what about the new trends of in 2026? How we are going to? What we are mainly talking about is the elephant in the room, like the large language model and the geospatial knowledge. So this is will still not will not be trying to learn that side, but it will be useful to try to think of framework how we are going to approach learning Earth engine when the current trends of the spatial files there. So when it comes to large language model, they have a very advanced ability to generate scripts. So to also like turning analysis into interactive, this is a very useful way of using large language model to build these apps that we were building about it. Of course, you can always use them as your coding assistant. There is the other part when like you also need to think of where they struggle and where you have to utilize your expertise. And so knowing that the geographic output is correct, your research question, these are the things that you still need to hold on. Casual datasets, even if they could script on flawlessly, if the datasets that you are using is incorrect, that's useless. This simple analysis is worth doing, and more importantly, validate the results. So the question is not like should you use MLA? It's like how can you use it and rely on it without losing this ability for the fundamental stuff. This is similar to like the LLM and the skill ladder problem, which means that experts become an expert by struggling through the fundamentals. What happens if you skip the struggle? And this is the question here. The risk with that is not that an LLM will replace the expert. It's just that fewer people will become an expert by skipping the fundamentals. But on the good news side, the question that we want to ask: are you in the first place interested in becoming an expert in scripting and coding? Maybe not necessarily. Maybe you are just want to focus on your research question and domain of expertise. So what would be worthwhile is like struggle in a new way, not skipping the fundamental, but struggling in a new way. That is like utilizing large language model with what they are good at, and then also harvest your domain of expertise, defining the right question, interpreting your maps correctly, and deciding what the data sets, but most importantly, critically scrutinize the output against known values and design tests for when you use large language model, how you can reliably use this output. Because the question is, how can you trust the results or the skills that we're actually able? Well, there is Jeffrey Caldwell is a professor at McGill University and a visiting scholar at Google, who was looking recently at two interesting projects. One about using large language model in the classroom, and the other is about a cloud-based geospatial benchmark. And the cloud-based geospatial benchmark is basically a collection of remote sensing geospatial questions that were designed specifically to evaluate large language model. So they come up with a specific criteria about like how the question should be to evaluate the large language model. And this data is already published, publicly available, and it is obviously very useful to evaluate the performance of large language model. But here, the idea is we want to evaluate the performance of the script that we are going to use or not. So I actually had a conversation with Professor Caldwell 2 months ago with Esmaeel about like how we can use it in such a workshop, how we can use that. And then we looked at this idea of benchmark at the same time to design your own test. So when you use large language model, you also develop a small test, a benchmark, that you test that script that you generated so you can reliably use it. So we will also try to cover that aspect of using large. The other part that we also need to talk about in the 2026 is the geospatial foundation model. As they become more and more available and popular, it might be wise to also look at what they are and how we can use them to life. And one key aspect of that, this is what we're looking at, is the typical workflow with remote sensing. You get the remote sensing data. You need some remote sensing or geospatial level of expertise to process this data to produce a data that is useful for your research. So most of you in this room are interested in this last two pieces of the work. You want the data that is useful to your research, and then you want to apply your domain analysis capability to answer the question. And the wall is here between like getting this data, the analysis ready data, so you can apply it for your research question, and accessing this raw data and processing it in both sides. Geospatial foundation models, in some way or another, they have the potential to might skip that process of like the raw data and the remote sensing by reducing by looking at embeddings, as some sort of virtual data that can be used right away for analysis. And this is a very simplified version of AlphaEarth foundation model by DeepMind Google, when they use train this model on massive satellites data. And the embeddings is this latent representation of all this data that is extracted and produced as if standalone data set that could work as a virtual satellite. So you can import this data now, which is the latent representation of this massive data that were ingested by the foundation model, and you can utilize it for research.
Esmaeel, can you just back up for 1 second and sort of describe at a really high level what a geospatial foundation model is? Because probably some people have never even heard that.
Correct.
True.
Exactly. So we have, there are by itself, geospatial foundation model, we have different specialized geospatial foundation model and also non-specialized foundation model.
Or just what a model is.
But by definition, what we are trying to do is that we are trying to, the geospatial foundation model idea is that bringing something similar to large language model to the geospatial foundation point. That is mainly about the queryable bit. What it means is that instead of going through the entire analysis, is there a point when you can ask the questions and get the answer? Not just by large language models answer, but by actually executing actual analysis and getting an answer. So this is where the general umbrella of designing geospatial foundation model is. It goes into very specialized area. There are so many different paths to doing that. And there is also, in many places, it's important. Our focus with this up here, and especially with using embeddings, is that we then try to look at it as a new virtual data that might be useful for some sort of analysis, and will cut through the typical workflow of like extracting raw data and analyzing remote sensing data that can require a level of expertise. So this is currently one of the hot topics in geospatial analysis, and it might be worthwhile also exploring it. So in this workshop, we will cover an example of comparing doing land cover classification using the traditional way of extracting satellites data and how we do it. And then we will also look at how we do it actually with embeddings and with foundation models. When this data, it's also available as a web app for exploration. So this is how it looks like. So it's like a virtual satellite. The AlphaEarth embedding. It's not the only geospatial model out there. It's only one of many geospatial models. And it's produced as annual composite. So for every year, there is a one data set for the last 10 years. So coming here, like from this discovery, this to or now looking further into like about this workshop by itself. So there are general guiding principles to book like to consider, and we try to also cover that in this workshop, including looking at a real problem instead of like just looking at the concepts at all. So we look at the concept, but we can also look right away at practical application of that. We can also leverage the existing resources that is there as well. But more importantly, actually, we can also try, and the most challenging part is also tailoring it for the people in this room. And we have a really diverse group here, like from the level of expertise, from different schools and different research groups. So with that part, including covering any topic within this as an umbrella topic that would span from environmental health, land use, and agriculture, ecology, and carbon. And also, we will look at other niche and our outlier topic. So what we are trying to look at is trying to find the common grounds, not just for that will be serving several kind of obligations, and you can all of you can have actual piece, useful piece that you can take it. So the main focus of this workshop actually is we will be trying to really break this wall in both the traditional way of learning the analysis of accessing the raw data, learning the basic analysis required so you can get your own data and focus on the domain expert analysis that you want. So we will try to do that in both the traditional way and also we will look at some example in AlphaEarth.